Hello everyone, welcome to Join to Learn channel. So this is our second lecture of signals and systems. In this lecture, this is very important lecture I am telling you. Now in this lecture we are going to discuss about classification of signals, important topic. So entire signals will be classified into mainly two types. There is also one more type, we will also discuss that that in this video. But overall, if you have to say the classification of signals, you can say that entire signals are classified into two types. They are either continuous signals or they are either discrete signals. So now let us understand what is meant by what are meant by continuous signals and what are meant by discrete signals. Here I have written, so see, this is a short form. CTS means continuous time signal. Yeah, there is one more thing I have to say. So we, in the previous video, what did we see? We have seen that there are three types of signals, like one dimensional, two dimensional and three dimensional. In the entire BTech or undergraduation course, you will be discussing only about one dimensional signals. Two dimensional signals and three dimensional signals are discussed in your further studies like MTech or PhD. So the two dimensional and three dimensional not at all necessary for you. Just for the sake of definition, you remember them. Even in the one dimensional signal also, so whatever we are discussing, one dimensional signals also, the independent variable will be must be time. So only the signals which are varying with respect to time, those only we will be covering in our BTech signals and systems chapter. Signals and system subject. Only the signals whose independent variable is time, those signals only we would be covering. So whenever I am saying classification of signals, you must know that these are continuous time signals and discrete time signals. So I need not mention you time separately. As you know that only one dimensional signals whose independent variable is time, those only we would be studying here. Okay. See, now continuous time signals. So what is the definition? A signal whose amplitude is defined for all intervals of time is known as continuous time signal. Here comes a new word for you known as amplitude. So what is amplitude? So before understanding the definition, you should know terminologies. You would be getting some terminologies. So here the new terminology for you is amplitude. So amplitude is nothing but it's the strength of a signal. Strength of a signal. So I will discuss about this in detail. Let us consider practically. Let us come to our real time lives. So you would have gone to any function or in any school functions, you would have seen amplifier. There is a box called as amplifier. In this box there would be some LED light, red color light. It will be present, right? So whenever someone is delivering speech, this red color light will be blinking. So when he speaks loudly and for he speaks continuously, this light, red color light will be blown continuously. It will not get turned off, right? It won't be blinking. It will be continuously in red color only. So when he is giving in a low voice, like he is stopping for a while and then he is continuing in this way, if the person is delivering speech, then accordingly this red color light will be blinking. So this red color light is known as amplitude of that speech signal. So what does this amplitude is doing? It is measuring the strength of the speech signal and accordingly it is blinking. So this is called as strength signal. If you don't understand this example, let us take one more example, right? In hospitals and all, you would have seen ECG. You need not go to hospital. In many of the movies you must have seen ECG, like heartbeat. Would be measuring heartbeat with the help of some machine, and it will be displayed on a screen. So how it will be? Like this. So in this way the heartbeat is being measured. So this is known as strength of the heartbeat. So when the heartbeat is more like then you will be getting like this. If a person is dead, so it will be saturated, right? So this is known as amplitude. Means what is an amplitude? It is the strength of the signal. Here what is the signal? It is heartbeat. It is being measured on it is being measured with some kind of machineries which we don't know. and it will be displayed, the amplitude will be displayed on the screen. So this is nothing but amplitude. Now come to the definition. A signal whose amplitude is defined for all intervals of time. We will see with an example, don't worry. So this is known as continuous time signal. Whereas discrete time signal, what's a discrete time signal? A signal whose amplitude is defined for only integer values of time. Such signal is known as discrete time signal. Why I am saying digital is the third classification, which I told in the starting of the lecture. We will also see that. Okay, so continuous time signal, let us take an example. So very important, this lecture is going to be very important, because whenever you have to solve some problems in your semester examination, you will be getting problems also in the subject of signals and systems. That is why whenever you have to solve the problems, you should be perfect in this classification, right? That is why you have to listen this lecture carefully. So let me change the color. I am taking continuous time signal example. See, I have already said that independent variable is t, and this is my let me consider my signal as x of t. So okay, this is my signal. This is some kind of signal, whatever it may be. This might be your speech signal or your heartbeat signal, whatever you consider. This is some kind of signal. This is time axis, from where let us give some time values for this. Let us consider this as minus 8 seconds, and let us consider this as ignore this part. Let us consider this as plus 15 seconds. Your signal is being defined between minus 8 to 15 seconds. It has been measured for very short interval of time. What is the interval of time? For 23 seconds your signal have been measured. Let us consider this as a speech signal itself. You have spoken something for 23 seconds, and this that has been measured, and it is in this way. So what's the link between this signal and how is it related to continuous time signal? Means, see, in the interval where your signal is existing, you can see there is a signal, there is some amplitude of signal at every interval of time in between minus 8 to 15 seconds. If you consider this as 0, this is 0.1, 0.2, whatever you consider, there is a respective amplitude with respect to each and every interval of time, each and every instant of time between this interval. That is known as continuous time signal. So a signal which would be having for all the intervals of time. So 0.1 it would be there, 0.2 there would be some amplitude. So in this way, a signal whose amplitude will be defined for each and every instant of time in the given interval is known as continuous time signal. Now let us see what is known as discrete time signal. So after knowing this, then you get much clarity. I'll consider like this. This is 0, this is 1, this is 2, this is minus 4. Here amplitude I'll consider this as 3, this is my 4, this is I'll consider this as 2.5, and this I'll consider this as 1. Okay, now see, here the amplitude of the signal, again see, whatever it is the signal, this might be signal, either it is speech or whatever it is some kind of signal. So here the signal is defined only for integer values of time, like it is defined for minus 4, it is defined for 0, it is defined for 1, it is defined for 2. Only for the integer values of time there will be amplitude of that particular signal. But if you consider 0.5, so 0.5 an instant of time, if you consider 0.5, is there any amplitude for the 0.5? No, right? Here the amplitude will be automatically 0. So the signals whose amplitude is defined only for integer values of time are known as discrete time signals, whereas the signals whose amplitude is defined for all the values of time are known as continuous time signals. See, continuous time signals are denoted as x of t. See, I am telling you again and again, so you have to maintain, you have to prepare your you have to prepare notes on your own, so you can get many number of points by the concept which I am explaining. If you could understand this concept clearly, you could write at least 3 to 4 pages depending on this concept. You can write neatly, so that is your duty. Whereas this discrete time signal is denoted as x of n, or it is also denoted as x of closure bracket n. So discrete time signals are also known as sequence. Discrete time sequence, it is also known as sequence. Why it is known as sequence, we will see within a short span of time. Now let me give you one more example. Sorry. This is 0, this is 2, this is 3, this is minus 2 minus 3. Is this a continuous signal or discrete signal? You people have to answer me. Think for a while and then answer it in the comment section. This is t, as it is varying with respect to time, and this is the name of signal x of t. This is a continuous signal, right? Why? Because at every instant of the time in the given interval, there is some amplitude for this signal. So why I have drawn this continuous signal is, you have to represent this continuous signal in a mathematical form. So how it is done is, x of t is equals to what is the amplitude? Let us consider this as amplitude 2 and this as amplitude 1. X of t is equals to 2. Here 2 indicates amplitude. For which interval? Minus 2 less than t less than 2. In between minus 2 to 2, wherever you consider, the amplitude is going to be 2. And then what is the let us consider this also as let us consider this amplitude as 0.8. Again you have to write as 0.8 for which interval of time? Minus 3 less than t less than minus 2. In this interval of time, the amplitude is going to be 0.8. And again it is amplitude is 1 for which interval? 2 less than t less than 3. In this way, whenever you are given a signal, you have to write its mathematical form. You should be able to write the mathematical form, and vice versa. If the mathematical form is given, then you have to write the what do you say, you have to draw the signal. In the same way, when it is when it comes to sequence, I am considering a sequence. Let us assume like this is 2 and this is 0.8 and this is 0.2 and this as I am considering this as 3. Here it is 0, 1, 2 and what is this? Minus 1. So how this sequence is written is, see carefully, x of n is equals to, first of all you have to write the entire amplitudes. What are the amplitudes? 3, 2, 0.8, 0.2. So where is the origin? I mean 0. Where is the instant of time whose value is 0? It is at the amplitude of 2. So you have to simply indicate this with an arrow mark. So what does this an arrow mark indicates? It indicates that origin is present at the amplitude 2. So you have to see respectively after 0 what will be present? 1, right? So this will be 1. This is 2. It means time interval 2. Time interval 3 seconds. At 3 seconds, what is sorry, this is 0, right? This is minus 1 second. So at minus 1 second, what is the amplitude? 3. So like this. Since you are writing this in the form of sequence, that is why discrete time signals are also known as sequences. So there is one more classification, right? There is one more classification I have said. Before going into that classification, I will give an example. You have to solve it on your own. You'll take it as your homework. See, x of t is equals to 1.5 for the time interval of 2 to 3. Then it is minus 2 for the time interval of 3 to 5. Okay, this would be enough. Draw this continuous signal. Then I am giving one sequence. X of n is equals to 1 1.5 to minus 1.5, and this is the origin. You have to draw this sequence as well. This is a discrete time signal and this is continuous signal. Mark it as your homework and do it on your own, and yeah, this will become a practice for you. What I have to say, yeah, there is one more classification, guys, right? What is the classification means? Digital time signal. This is not important for us, this is for higher studies, but still you have to be aware with the definition at least, right? You cannot completely ignore this signal. Very simple, very simple. This digital time signal is also this signal will also comes under discrete time signal. That is why we have not separately classified this. It is also a sub classification of the discrete time signal. So before going to digital time signal, let us recap what was meant by discrete time signal. So discrete time signal, let us draw one. This is 1, this is 1.5, and this is 0.5 or 0.8, 0, 1, minus 1. Let us consider this one discrete time signal or sequence. So here we can clearly see that it is only defined for the integer values of time. Well and good. Now if you can see the amplitudes, these are not integers. Amplitudes are, few amplitudes are going to be integers, like 1 is an integer, whereas 1.5 is not an integer, it's a rational number, or you can say it's a fraction which is having some value after point, like 1.5, 0.8. So discrete time signal, in discrete time signals only the time is going to be integer, but whereas amplitude is not. So for such kind of signals, what we will do is we will pass these signals through quantizer. This is not important, I'm just telling you, you have to have an idea. So what will happen after going through the quantizer? This signal is passed through quantizer. What this quantizer will do is it will trim these amplitude values and round it off to nearby integer values. So what does it mean? Means like here it is 1.5, right? It will be rounded off to 1. So after passing through quantizer, what will happen? 0.8 will be rounded off to 1. 1 is integer, so it will not be trimmed. Again 1.5 is not an integer value, it is some fractional value. Again this after passing through quantizer, this will be rounded off to nearby integer. What is nearby integer for 1.5? If it was 1.6, it would have been rounded off to 2. Since it is 1.5, it is rounded off to 1. So 0, 1, minus 1. These are known as digital signals. Means the signals, one second guys, the signals whose time as well as amplitude or integer values are known as digital time signals. Whereas what are known as discrete time signals? The signals whose time are just integer values, not the amplitudes. Amplitudes can be any value, they can be fractional, they can be integers, whatever it might be. But whereas digital signals are the signals whose amplitude as well as time values are integers. Okay. So this is about the classification of signals. You will be having number of problems to practice on these classification of signals, but I can't discuss them right now because for practicing you have to have an idea on a concept called as operations on signals. After discussing that operations, then we will do practice on these signals. So it is very important topic. You will be getting practice, you will be getting problems from this topic only. So we will discuss those problems also once our operations on the signals topic is covered. Okay, then thank you. If there is any feedback you have to give on my teaching, you can give it in the comments. You can mention it in the comments. That's it from my side, guys. Thank you. We'll catch you up in the next video.